Hello everyone and welcome back to our course. In this lecture, we are going to continue analyzing our data by building out more plots. All right, so next up, we are going to build out a box plot. So I'm going to create a new code cell here. I'm going to grab my data set and I'm going to create a box and whisker plot. I'm going to use the plot function. The kind is going to be a box, and that is going to create for me a box and whisker plot. Subplots we will set to true. The layout we can set 10 by 10. And that is going to be the number of different values that we have. Okay, I'll have share x be false and share y be false as well. Then I will call pyplot.show to ensure that we are showing our data set. Now pyplot we have to import. At the top of this code cell, import matplotlib.pyplot as pyplot if you want to actually use the pyplot library, which you do. Okay, we'll run that code cell and just give it a moment to generate our results. Okay, that's quite small. Let me just make this a bit different of a layout. We'll do 3 by 3. Okay, there we go. So we can even do 2 by 2. That's going to be just the shape of our layout. You must have at least 3 by 3 though, because we have 9 different values to plot. So it depends on the data set, but in our case we have 9 different plots, so that is what we will put here. That is a bit small, so we can add another argument here. That is our fig size, which is the size of our figure. We could do 3. All right, it has to be 3 by 3 though. We have to do width by height. All right, and okay, that's going to change the size here of our figure. I could do this 9 by 9 to make it even larger, just to make it easier to see. Okay, here we go. I'll make it even bigger. Let's do 20 by 20. I just want to make sure that we can actually read the box and whisker plot. Okay, here we go. So we can see we have our box and whisker plots. We can look at them all individually as well. We have our different columns: open, high, low, close, adjusted close, volume, decrease, buy, and returns. So this box and whisker plot is going to show us the distribution of our values, and the box is going to show us the average distribution, and the dots, those are outliers. All right, next up, let's create another type of plot known as a histogram that will show us the frequency of values. So let's make another code cell. I'm going to grab my data set and use the plot function again. This time, however, I'm passing in my kind argument as hist, short for histogram. Subplots is true. The layout, I can do the same 3 by 3 as last time. Share x is equal to false and share y is equal to false. And then we have our fig size. We can do 20 by 20 again. All right, then I will call pyplot.show to ensure that we show the previous plot in this code cell. And here we go. Look at this. Now we can see each of the columns in a different chart, and we have the frequency of the different values. On the y is the frequency. So if you only have one range, then there's only one bar. But if you have several different ranges, for example, for volume, then you have several different bars, and we have the frequency of each range of the bar. You can also then see here, mostly the interesting one is the volume here, because that's the one that actually has different bars here, because we can see that the range of 0 to 0.25 was most frequent. It appeared 530 times. The range of 0.25 to 0.5, that was the second highest in frequency, and so forth. We can also create a histogram really quickly with dataset.hist, just like that, then call pyplot.show. That's going to create a quick rendering of a histogram, although we didn't really pass any size here or anything, so it's just the default that's created. You can see there actually is some variation with open, high, close, adjusted closing price. There actually is a little bit of variation. It's just hard to see. Okay, here I can pass in a fig size. I can do 20 by 20 for the hist function. That's just going to make it a bit easier to see. Okay, we have open, high, and low. And then we have on the Y is the frequency, and on the x is the range. So for something like the closing price of the stock versus volume, they'll have a different x-axis because they represent different values. Close is a value of the stock, and volume is, here it's in 1/8, which means it's the number times 10 to the power of 8. All right, so 1 with 8 zeros at the end. So volume is much larger than close. That's why we have different x-axes. All right, next up, let's build out our classic line plot. So this will show us the distribution of our features. I'm going to call dataset.plot. This time the kind I'm going to set to line. Then subplots I will set to true. The layout I'll do the same 3x3 because we have 9 different features. Share X again is false. Share Y is also false. And then fig size we can do 20x20 again. Then I will call pyplot.show to show our plot. Let's let the code cell run, and there we go. We have again one graph per every feature or column, and we can see the line plot this time. Now the line plots for the different stock price columns like open and high, those are going to be very similar because typically during the day the value of a stock does not change that much. Then we also have volume. Now that is a lot more volatile because that is the number of trades per day. Now for decrease and buy, we have some interesting values. You see, these are categorical values: decrease or increase in volume, and then buy or sell. Those are categorical, therefore you can't really make a line plot out of those. So instead we just have these colored boxes. We can just ignore these really. Then we have returns. All right, so that's how much of a return you would get, and you can see the Y is from -2 to 0.2. So you can see that the range of the returns never left that min and max. All right, and those are just a few of the different plots that we can create. There's a lot more that we can create. For example, we can plot all of the different stock prices on one plot. So to do that, I'm going to create a new code cell. All right, and let's hop into that. I'm going to define my stock prices. All right, I'm going to grab my data set, and using 2 square brackets, we're going to allow us to access different columns of the data set. I want the open column, the high column, the low column, and the edge close column. So that's going to only take those 4 columns from the data set. And then I can call pyplot.plot, and I'm going to plot the stock prices. Then I'll call pyplot.show. All right, then I can run this code cell, and here we go. We can see here the plot function just plots the data set with its default plotting. And we have different colored lines this time. So if I want to add a legend, I just call pyplot.legend, and I pass in the stock prices data set, which is my X. And then I get this little legend that's drawn as well. So here we now have a legend that says what line means what. As well, we can plot different features against one another. For example, we know that because these lines are so close together, that the different stock price columns have almost a linear relationship because they are almost exactly the same. So what we can do is we can actually plot one versus the other. I'm going to make a new code cell. I'm going to make a pyplot.scatter plot. I'm going to grab my data set. I could also grab stock prices, doesn't matter. And I'm going to grab one of the columns, for example, open. And then I can grab the data set and I can plot a second column, close. And I'll call pyplot.show outside of that function. So now we'll have a scatter plot being generated. Here we go. And this is going to show us the X here is the first entry, open. The Y is close. So let me just add that here. I'm going to add pyplot.xLabel to set the label of the x-axis. I will set that to open. Then I'm going to call pyplot.ylabel. The y is close. All right, then I'll rerun this code cell just to make it a little more clear. So the y is the closing price, the x is the opening price. And we're creating a scatter plot out of those. If this line was perfectly straight with no variation at all, then close and open would have a perfectly linear relationship. But because the opening price of a stock on a given day is different from the closing price of a stock on that day, that's why we have some variation here. But the relationship is still very, very similar, very close to linear, very close to a one-on-one relationship. All right. Coming up next, we're going to build out more plots. So join me in our next lecture where we will learn how we can visualize more features of our data set.